Greetings, Houdini Python users. This is the second portion of our exploration of using Houdini Python to solve a real-world production issue. We started the solution by generating a fancy Python expression to compute the distance between corresponding points in two objects. Now, in this session, we're going to discuss how the Python SOP is created. Now, here, this is a little reminder of our Python expression. We used the vector3. We created a new vector3 object, and then we used its distance2 method in order to create two different, to output the distance value, which took as input the local point position of the first object and the point position of the second object. All right, now once the distance was computed, we need to create a Python SOP which will take in the distance attribute, transform it into color, and assign it to that point. So I'm going to create a new Python SOP. I'm going to File, New Operator Type, and then we have this. I'm going to call it Distance Fall Off. All right, and I'm going to make it look fancy for the label. Distance Fall Off. All right, now we want this to be a Python SOP, and we want to make sure that it is definitely a geometry operator, and I am going to create a distance fall off OTL and click accept. Okay, and then we want to install this into the current HIP file only. I'm going to click accept. Okay, now we have our type properties window, and we've gone right to the code, and we have the basics, the parameters. Okay, we should be good to go. Now I'm going to go right to the code. Oh, I'm sorry. What I need first is a fall off parameter, and this is going to help us dial in the color when we're ready to go. So I'm going to go and grab a float widget, drop it on root, and I'm going to call this guy fall off. Okay, fall off. We're going to see how to use that in just a little bit. Now I'm going to go to the Codes tab, and now we're ready to use the code. Now, as a reminder, for any Python SOP, Houdini will automatically take the node name and assign it to a node variable, and take its geometry and then assign it to a geometry variable. So now we're ready to rock and roll with whatever it gave us. So now we're ready to start authoring. And what I want to do first is create a attribute for the color for this, since we're going to be manipulating its color. So I'm going to create a new local variable, cd equals geo.addAttrib, and the arguments for that method are who.attribType.point, cd, which is the color, and initial value, an initial color of 1, which is all white, of course. Now what we're going to do is we're going to cap the fall off param. Now we're going to grab that fall off parameter that we generated before, and let's see. Okay, what this means, we're going to create a new local variable called fall off, and then we're going to say max of who.ch, meaning grab the current channel value of the fall off variable, and we take the max between that value and 0001. Because we're dealing with real small numbers here, we want to give it some kind of limit to prevent numerical inaccuracies. Now we're going to go through all of the points in the head and process its color based on the deviation. So all I'm going to do is iterate on all the points in the head. So I'm going to create for point in geo.points. All right, then I'm going to go and I'm going to create a distance value, which is going to grab each and every attribute of the point. So I'm going to grab the point dot float attrib value dist, and so what it's going to do, it's going to access that attribute, the distance attribute that we generated in the last session, and it's going to assign that value into the dist value. Now we're going to create a new local variable called value, and that value is going to take the dist value that we just accessed, and we're going to divide it by the fall off that we created before here, and then we're going to cap that at the value of 1. So we have the minimum things. So what we're going to end up with is a value somewhere between 0 and 1. And the reason for that is because we're going to use that to help modulate our color value. And to do that, we're going to create a color variable, and we're going to use the who.color class. Now the who.color class is really cool because it creates a whole bunch of color types, and it controls how to manipulate each of these colors according to the space that you create. And so what we're going to do now is say color.hsset HSV, and what we're going to put inside is a tuple based on the value. Now HSV is hue, saturation is value. So for the hue value, we're going to take that value that we computed earlier and we're going to multiply it by 256. For the saturation, we're going to put in a value of 1. And for the value, we're just going to use the value that we created again. Okay, let me round up the parentheses on that. And one thing again, we are using the point, or we're using the color method, or the color class in there. And what we're going to do now is going to take that hue, saturation, and value, the HSV value, and we're going to grab its RGB value and put it in a set attrib value method. So we're going to take the point, and for every point, we're going to set its new attrib value, which is the color, or the CD value, and we're going to assign it the color.rgb, which is really the HSV value. It's just that Houdini does that translation for us automatically. I'm going to hit apply, and okay, hopefully we don't have any errors. So what we have to do now is we have to actually create a SOP for it. So what I'm going to do is go into my window, network window. I'm going to hit the tab. I'm going to go to digital assets. I'm going to grab a distance fall off, and I'm going to create an output from my point into the distance fall off, and I'm going to click there. Okay, we didn't get any errors, which is good. We're in good shape. So now all we have to do now is we've got this fall off variable, and now we're going to have to dial this in to some presumable value so we get some kind of reasonable information out of this. So I'm just going to dial this in here. And it looks like we're getting some good information. See, everything is turning kind of mottled yellow-orange, really ugly looking, except for a couple of regions. Aha, and these are the regions that we're looking for. It looks like we've got a couple of bad regions in the lower eyebrow and in the upper cheek. Let me dial that in a little bit for the lower cheek. All right, good. Now we really identify where the problematic areas are. Okay, good. Okay, now that we've identified those problematic areas in our head animation system, we now understand how much deviation from the DCC the game should be allowed. Now, the areas of extreme color identified by the problematic areas where our facial anime system is breaking down. So we now know that our facial anime system is broken down in the eyebrows and in the cheeks. And in this case, the purple regions express the greatest deviation beyond the drab olive yellow. And to wrap things up, during the last 2 sessions, we applied Houdini Python solutions to resolve a real-world production issue. We wrote a very fancy Python expression to compute the distance between 2 corresponding points and assign the value to a new attribute. We then created a Python SOP to take that distance and map it to the vertex color in order to identify the problematic regions. So now our programmers could go and identify what is wrong with the cheek and the eyebrow. Now, in the next class is a bonus class dealing with the Python session module within Houdini. I'll see you in the next lesson.